schema design and trade-offs. Let's have a look at what the actual data looks like. This is just an example, and each e-commerce will have its own peculiarities, but it's simple enough and it's useful as a framework. We use dimensions, such as product catalogue, territories, categories, brands, and facts, orders or transactions, as our data tables. There are many different ways to model the same thing. We use this traditional approach of dimensions and facts tables. Dimension data is everything that doesn't grow linearly with time, or if it does so really slowly. For example, the product catalogue grows, but nothing like at the same rate as orders, assuming of course you have customers. Other examples would be stores and countries. You don't expect these tables to go for several million records. Facts are something that grow every day. Orders and changes in stock, for example. Think of these tables as tables of events. This is the table diagram we're going to use for this course. In order to understand what's going on, we'll refer back to this schema to know where we are. Not everything may make sense now, but it will during the course. We have our fact tables of orders and stock in light blue, our dimensions tables of products and locations in green, RT means real time, obviously, and MV means materialized views. We'll come back to that. Let's take a closer look at our orders table. It has these typical fields. ID, a unique identifier for the item. Order ID, items can be grouped by order. State for the item, for example, paid, returned. Location, from where the item was bought. Timestamp, time when the sale took place. There could be more dates. SKU, stock keeping unit. An item reference with all the possible details, colour, size, quality. Quantity, how many items. Amount, the amount in the local currency, or maybe not, we'll see. Sales tax, the rate or amount. Warehouse, where the order was delivered. You can have many more fields, and you will have, for example, information about users, shipping, and so on. But these are the ones of most interest to us. Why aren't we splitting orders and items? Simply because we'll do that later when we generate the materialized views. What are the relationships between tables? Orders or items are usually related to a products table and a stores table through SKU and location respectively. These tables contain extra information about products, classification, hierarchy, and stores, location, the country where the sale was made, the exchange rate for the country, and so on. There are many more relations between tables, but in general what you need to ask is, could I denormalize them, and if so, is it better to do so? Denormalization is the process of trying to improve the read performance at the expense of losing some write performance by adding redundant copies of data. Sometimes, even if read performance is better, keeping normalization is better to evolve the project. You need to consider how often the relationships change. The loading order is also important. We'll come back to that. Let's think about which relations should be denormalized and when it makes sense to do so. For analytics, it's usually much better to denormalize as much as possible and avoid joins, but that's not always possible. For example, product characteristics do not usually change, so you could denormalize and save them with the orders information. But sometimes you can't, because the insert order is not guaranteed, so when orders data for a product arrives, the product information may not be there. For characteristics that do change over time, such as exchange rates, you may want to store the rate that is current at insertion time. But you may want to use today's rate when the analysis is performed. Recommended data types, compression, precision. In general, the less space the columns take, the better. These use cases are usually limited by the amount of data you can transfer from memory to the CPU. To help with that, we usually use LZ for compression. It provides a good trade-off between the compression ratio and decompression speed. You also need to think about precision. Storing money in a float 32 is not the best approach, because in this case the error is going to be really low and the speed up is massive if you compare with other data types. What should you do? A simple solution is to work in cents, not euros. Then everything is an integer.